Pedigree is a family tree that shows the presence or absence of the specific trait in each member of each generation. We can predict that the particular trait is due to dominant allele or recessive allele. So, with the help of pedigree, we can analyze the inheritance pattern of the particular trait. Four types of pedigrees are autosomal dominant, autosomal recessive, X-linked dominant, and X-linked recessive. To form a pedigree, we have to use various conventions or symbols. To represent a male, square symbol is used. For the female, circle. Then a square is connected with a circle through a horizontal line, that is the marriage line. If the marriage line is double, horizontal line is double, that is indicating that male and female are relatives of each other, like in case of cousin marriages. Then here is a small pedigree showing the parents in the first generation. And then from the marriage line of parents, a vertical line is drawn downward. That vertical line is further connected with a sibship line. Sibship line is showing the siblings or the offsprings of these parents in birth order. So here is the first son, second daughter, third son. So these offsprings are shown with Arabic numbers, while generations are represented with Roman numbers. To represent identical twins, there is a symbol in which sibship line is further connected with two diagonal lines, and then symbol for the twins is there. So here two females are shown with a horizontal line that is connected these females. That horizontal line between these two females showing that females are identical twins of each other. In case of fraternal twins, same symbol is there, but horizontal line is missing. That is indicating that these females are fraternal twins of each other. Identical twins are monozygotic twins, so sex or gender of offsprings must be same. But in case of fraternal twins, as they are dizygotic twins, so sex or gender of the twins might be different. If the disease is present in the affected, in the male or the female, so it means they are affected, or to represent affected male and female, colored symbols are used. Here's a colored circle that is showing affected female, and the colored square that is showing affected male. Then here is a symbol of circle and the square with various lines that is indicated that male and female are affected by history, means disease is present in previous generations. Then here is a symbol of circle with a dot that is indicating the carrier female. Carrier female means that female herself is not affected with the disease, but she has ability to pass the disease in the next generation because she carry an affected allele. Carrier male or female are only present in case of recessive disorders. Then here is a circle symbol in which diagonal line cross it, and similarly square with a diagonal line that is indicating the deceased female and male, means they are not alive. To represent unknown sex, diamond symbol is used. Here is our autosomal dominant pedigree, and you can see here that both generations are affected, and that is an identification of dominant disorder, that dominant disorder mostly present in each generation, while recessive disorder can skip the generation. And in case of autosomal dominant disorder, you can see here parents are affected and they affect their son while their daughter is normal. So it means they affect 50% of their offsprings while 50% are normal. So that is indicating that parents are in heterozygous condition for the dominant allele, because they just affect their 50% offsprings. So suppose if A gene is causing a dominant disorder, A gene has two copies, one is dominant copy, other is recessive copy. So dominant copy can cause the disease. So parents are present in heterozygous combination. So that's why they pass their dominant allele to their son and they pass their recessive allele to their daughter. So their daughter is normal, but their son is affected. This pedigree cannot be recessive as two affected parents could not have an unaffected offspring. Next is the autosomal recessive pedigree, and here you can see generation is skipped. Parents are normal, but they affect their daughter. So basically, these parents are carrier of recessive allele. Suppose we have a B gene, and B gene has two copies. One is dominant copy, other is recessive copy, and recessive copy can cause the disease. But recessive copy can cause the disease only in case of homozygous condition, when small b and small b combine together. It means parents are carrier of recessive allele, and when both recessive alleles passed by parents to the daughter is affected, but their son is normal as son received a normal copy by parent. So this pedigree cannot be dominant as two unaffected parents could not have an affected offspring. Parents must be heterozygous. Next is the X-linked dominant pedigree, and here you can see each generation is affected, and X-linked disorders follow a crisscross pattern of inheritance. Here you can see mother is affected in the first generation. She affect her son, and that son further affect females in the third generation. So that is a crisscross pattern of inheritance. Trait passes from grandmother to granddaughters through son. So here is a X-linked dominant pedigree, and you can see here that female is affected. So female carry two X chromosomes while male carry a single X chromosome along with Y. So here female is affected with X-linked dominant disorder and she passes the trait to her son. Father cannot pass the X-linked trait to his son because father passes only Y chromosome to his son. So here male is affected with X-linked dominant disorder in the second generation. That male further married with a normal female, but they affect further their all daughters. You can see here in the third generation, there are two sons and four daughters. All sons are normal, but all daughters are affected. So that is indicating that father in the second generation passes only Y chromosome to son, but he passes his X chromosome to all daughters. As his X chromosome contain an affected copy or affected allele, it means affected dominant allele passes by father to all his daughters. That's why daughters are in heterozygous condition, but they carry a single dominant allele and dominant allele can express itself phenotypically. The last is the X-linked recessive pedigree that also follow a crisscross pattern of inheritance. You can see in the first generation, male is affected, that further affect the female, and female further affect the males. So here, X-linked recessive pedigree or X-linked recessive traits are most common in males in comparison to female. Reason is that male contain a single X chromosome, so males are hemizygous for X chromosome. So if single X chromosome of male carry a recessive copy, it will express itself phenotypically. But for the female to express a recessive disorder, both X chromosomes of female should carry a recessive copy. So female must be homozygous to express a X-linked recessive disorder, but males are hemizygous, and if single copy of recessive allele is present on the X of the male, it will express itself phenotypically. So that's why X-linked recessive disorder are most common in males. So you can see here that father is affected in the first generation and he passes the trait in his daughter. So daughter receive a single X by father Another X in the daughter comes from mother. So if daughter is affected with recessive disorder, it means that daughter should be in homozygous condition for the recessive allele. So it is indicating that female or the mother in the first generation is carrier of the recessive allele. So she passes her recessive allele in daughter, and another recessive copy is received by daughter from father. So she is present in homozygous condition for X-linked recessive allele. So she is affected. Further, she is married with normal male, but she affect her all sons. In the third generation, you can see here 4 sons and 2 daughters are there. 2 daughters are normal, but sons are affected. So it is an identification of X-linked recessive disorder that if female is affected, if mother is affected with X-linked recessive disorder, then all of her sons must be affected. Again, if mother is affected with X-linked recessive disorder, then all of her sons must be affected because sons received single X chromosome by mother. And if father is affected with X-linked dominant disorder, then all his daughters must be affected. So here again, the 4 pedigrees are there. The first one is the X-linked recessive pedigree. You can see here generations are skipped. In the first generation, parents are normal. They further produce 4 offsprings, 1 normal daughter, 1 affected son, another normal daughter, and second normal son. So basically they have 4 offsprings, out of which 2 daughters are normal and 2 sons are there. 1 son is affected and 1 son is normal. So if son is affected with X-linked recessive disorder, that is indicating that mother is present in heterozygous condition. So here the genotype of the mother is heterozygous. So she is carrier of the recessive allele and she passes her affected allele to son. That son or male in the second generation is further married with a normal female and they produce 2 children and both of them are normal. So it means as father is affected with X-linked recessive disorder, he passes his recessive copy to his daughter, but daughter received normal copy by mother. So that's why daughter is basically carrier, but carrier person phenotypically is normal. So again in the second generation, you can see here that daughter is normal. She is married with a normal male and here they produce an affected son. It means in the second generation that particular female is carrier. That's why she affect her 1 son. The next is the autosomal dominant pedigree and you can see here in each generation disease is present. So here father is affected. He further affect his 1 son and 1 daughter, while his another daughter and son are normal. So it means here father is affected with autosomal dominant disorder, but he is present in heterozygous condition. That's why he affect 50% of his offsprings, while 50% offsprings are normal. So again, in the second generation, that affected male married with a normal female and they only affect their 50% offsprings. Again, that is indicating that particular male in the second generation is in heterozygous condition. That's why they affect only 50% offsprings. Here, female is affected in the second generation. She is married with a normal male and they produce all normal child. It means female although carry a dominant copy or the affected copy, but she does not pass the affected or the dominant copy to her offsprings. That's why offsprings receive single copy by the mother, that is a normal copy, and they all are normal. So dominant autosomal disorders equally affect the male or the female. The third is autosomal recessive pedigree. And here you can see generation is skipped. First generation is normal, second is normal, and disease is present in the third generation. So basically that is indicating that in the first generation, where both mother and father are shown as normal, basically one of them might be carrier of the recessive allele. So he or she passes the recessive allele to their daughter, as daughter is a carrier of recessive allele. So she is married further with a normal person, but that male is also carrier of recessive allele. So both parents in second generation are carriers of the recessive allele. So when they passes their recessive copies to their offsprings, offsprings come in homozygous condition for the recessive allele and they express the disease. Last is X-linked dominant pedigree. Each generation show the disease, and in the first generation, female is affected with the dominant disorder. She further affect her daughter and son, while her another son and daughter are normal. So it means that female is present in heterozygous condition because she has two X chromosomes. One X chromosome carry a dominant allele, another X chromosome carry a recessive allele. So she passes dominant allele to her 50% offsprings, while recessive allele to another 50% offsprings. So those offsprings that receive dominant copy are affected, while the other that receive recessive copy are normal. So here, female is affected in the second generation. She further married with a normal male, and all of their children are normal. So it means these children did not receive a dominant copy by mother. They receive a normal or the recessive copy by mother. So it means mother is present in heterozygous condition. Then next, here father is affected with a dominant disorder and that further married with a normal female, but they affect all daughters. That is indicating a X-linked dominant disorder because as I said previously that if father is affected with X-linked dominant disorder, then he must affect all his daughters because daughters receive single X by the father and that single X by the father carry a dominant copy and that dominant copy can express itself in heterozygous condition. So these are all, that's all about the pedigrees.